Well, my name is Kyla Jeffrey. I'm the Director of Challenge Success on the HeroX team. So I have the pleasure of being able to support these folks from NASA and BOEM on this competition. I'm going to hand it over to Lynn for a quick introduction to you, Lynn.
Okay, hi everybody. I'm Lynn Bucco. I manage NASA's Center of Excellence for Collaborative Innovation. And as part of that, we host a suite of tools we refer to as the NASA Tournament Lab. HeroX is executing this challenge for us through the NASA Tournament Lab. And my role in this is really to just help this team who is experiencing the use of crowdsourcing really for their first time. So it's a great project to be a part of.
Awesome. And Lynn's actually at crowdsourcing this week. So if anyone else is in kind of the crowdsourcing space here, HeroX has a booth too. Really cool for you to come say hi.
Yeah, I'm Washington, D.C. right now.
Awesome. Jake.
Sure. Hi, everybody. I'm Jake Levinson. I am a marine biologist that works for the Department of Interior's Bureau of Ocean Energy Management. We're the ones that oversee things like putting renewable energy wind turbines in water, sand mining, and energy development in U.S. waters. My job is to look at impacts and of where things go, really, to put it simply. I want to know where whales go, where turtles go, and how activities out there in the water can impact them. And so that's what brings me here. I'm the guy that focuses on things in the water mostly.
Great, thanks, Jake. Andreas, I'll pass it over to you now.
Yes, good morning, everybody. So my name is Andres Martinez, and I'm with NASA headquarters. I am a program executive within the Advanced Exploration Systems Division. My focus as a program executive is with small satellites. We have several missions going as far as deep space. A couple of them are going to be orbiting the moon. But one of my most interesting projects right now is the study that we're undertaking with BOEM and Mr. Jake Levinson. So we are here to support the definition of the next generation of animal telemetry. We believe that we can do significantly better than what we've been doing. So we're here to assist Jake and his community of scientists.
Great, thank you, Andreas. And we also have Carol on the phone. Carol, it would be great for you to introduce yourself.
Good morning, everybody. My name is Carol Galicka, and I work in Advanced Exploration Systems at NASA headquarters. And I'm primarily here to support CubeSats. I manage the CubeSat Launch Initiative, where we offer launch opportunities to nonprofits and educational institutions.
Fantastic, thanks, Carol. So what today's going to look like is Andreas and Jake are going to go through an overview of what the challenge is all about, why this is so important, why they came together to work on this project. After that, I'm going to show you a little bit about the competition portal, what that looks like, and then we'll open it up for a Q&A. So as we're going through, if you have any questions that come up, there's a Q&A box on your screen. If you click that to open it, you can put your question in and we'll receive it. So please do so. You can post them in there at any time, but we will answer them all at the end. There's also a chat, as everyone has seen. So again, please continue to introduce yourself. Fantastic to see everyone here from all around the world. We've got some World Wildlife Fund, Zoological Society of London, universities from all over. Really, really fantastic. And please do put your questions in the question box and not the chat, so we make sure we don't miss them in some of the other conversation. So with that, Jake, I'll hand it over to you.
Sure. Well, thank you everybody for joining us today. Let me just figure out how to share my screen here real quick. There we go. Share that like so, right? And now you guys should all see my screen that I'm sharing.
We do.
Okay, hold on, make sure I can. Okay, great. So thank you all for joining. Like I said, my name is Jake Levinson, and I work as a marine biologist for the Department of Ocean Energy Management. This all started out of sort of a frustration of mine that the data that we get from tagged animals is really limited. And and I ended up sending a note to NASA, and somehow that got in the hands of the right people. And they said, yeah, let's talk about how we can help you make this better, because I think we can work together to improve that. And so, and then sort of this project was born. The goal being to find a more cost-effective, open source way to track marine megafauna, which is really just a fancy word for saying big things in the water. Anything that can carry a tag, we're interested in following. Tagging isn't the only science that we use, but let me tell you a little bit about the project here. You know, across the federal government, across academia, across NGOs, we all have need for various reasons to understand where wildlife goes. And we can understand where wildlife is, how they're distributed, how many there are, and where they travel through a lot of different ways. We can take pictures of them if they have unique markings. And then if you see those unique markings again, you can get an idea of their travel. We fly planes and take boats out to do surveys, but that costs a lot of money. And satellite tagging is actually another way that we get important animal data, not just on their migratory behavior or their movements of individuals, but also about range, about their behavior, how they're foraging, what they're doing on various spatial scales. And that's really important data. At BOEM, where I work, we use that data to better understand planting areas. So if we have a wind energy planting area or a marine mineral borrow area and things like that, we want to better understand what animals pass through that area and how they might be impacted, how they're using that habitat around them. And we can create density maps like what you see in the middle here. I think this is an example of pilot whales in Hawaii. We can understand where they go. But it's not just me in the ocean. It also is rangers on land at national parks looking at wolf movements, or folks in Antarctica looking at seal movements. It's folks in the Philippines looking at movements of endangered hawksbill turtles. So this is a problem that exists all over the world, really. Oh, whoops, I think you guys just, there we go. Can you still see my slides?
Yes, we can still see them.
Okay, great. So just making sure that, okay. Sorry, so this is all over the world. And so sea turtles, you can see the little tag there. That's a very simple tag from wildlife computers called a spot tag. It just sends out basically a little beacon every time that hawksbill turtle surfaces. And then satellites pick up and calculate an approximate position of where that turtle was. But there's some challenges with this in terms of data quality. For example, animals like this hawksbill turtle that only are up for a second or two and then dive down, you might not get the best quality location signal. And so I was interested in, can we improve upon that by increasing the satellite coverage overhead or other ways? And so you can see the tag on the back of the animal there. I'll move my mouse around it if you can see it. Every time it surfaces, a little wet dry sensor goes off. It knows the tag is dry and it goes, okay, it's time to transmit. We also use tags on bigger animals. So this is a whale shark. This is the world's largest fish. And you can see that line trailing about. In the back there has a little torpedo shaped thing. That's the same idea as a very small spot tag, just a little beacon that when the whale sharks spend a lot of time at the surface and will slow down and feed or hang out right, in the first foot of water. So that little tethered tag floats up at the top and sends a signal off and then goes, and rides along on the coattails of the shark until it surfaces again. So tagging technology has changed a lot. This is a picture that a friend of mine used in a presentation that I love to use too, so I steal it from him. But it's a screenshot from the movie Jaws, where they basically kegged the shark. They attach a harpoon to it with a barrel on it and hope and then follow the barrel on where it goes. This is pretty rudimentary, and we've come a long way. Tags are really small. Some of them are an inch or two, and they've come a long way. But the satellite infrastructure, there hasn't been a lot of changes on it. I think it's about time that we can make that infrastructure better. So this is a problem that happens around the world. And like I said, there are limitations in terms of satellite coverage. Right now, there's really only about 6 satellites, and I believe at least one of them is past their life expectancy. These are, payloads on big government satellites. But the satellite world has changed a lot since these satellites were launched, and now people are putting all these micro and small satellites in orbit, and there's a lot more of them. So it seems to me that if we could all be on the same page here, perhaps we could leverage all those small satellites to help us. This results in limited geographic coverage as well. So if you're a colleague of mine in southern Florida, or you're studying turtles closer to the equator, you may only have 10 or 11 minutes or so of satellite coverage every time for every hour that your turtle's out there. So think about that for a second. A turtle has to come to the surface, stay on the surface, while at least a couple satellites are going overhead somewhere between the two horizons, so that you can get enough satellite coverage to have a fix. So it's a very limited amount of time that you can get coverage for a satellite's orbit. And Andreas and Carol and Lynn, these folks know more about the satellite side of things than I do. I'm sure there are technical terms for, rather than saying a satellite flying overhead, but the point is that if we had more coverage, we might be able to get more data and better spatial accuracy. And so that's what we want to get. This picture here in this slide is an example from Alaska of how I believe those are walruses that are tagged. And walruses have need for sea ice and for hauling out, and we want to make sure that development doesn't happen in a way that impacts walrus haul outs. So we tagged a bunch of walruses to start to look at their behavior compared to areas, and we were able to exclude areas from development because they were walrus haul outs. So right now, there's a system in place called Argos, and Argos is basically a space-based system of payloads aboard 6 satellites, and these are special payloads that can detect the low power from animal tag transmitters. And data comes off the tagged animal and goes to the satellite, and then comes ashore to a data processing center. And then I can access that, and research can access that through an internet portal and get our data. And that's really all there is to it. There are some people making ground stations receive signals. So there are 2 companies I know of that make ground stations. One is a little handheld one, and one is a larger, basically a laptop GPS and then antenna all in one area. But those are limited sort of line of sight at sea level, or where the tag is, where the receiver is. So the vision that we've been talking about is really how can we have a more coordinated next generation of wildlife tracking systems. And there are things that have happened in isolated stovepipes and improvements, but what I'd like to do is sort of thread them all together so that we can have a system that can toggle between geographic areas and type of animal that is applicable, that can help improve our coverage. So on one side, this could be maybe a network of small satellites, whereas and that can improve the Argo system. There are weather balloons that go up and fly. There are experimental aircraft that go up and fly. There are drones. There are survey aircraft. All these things could perhaps be part of this new infrastructure, this sort of next generation of a truly connected ocean, a truly connected atmosphere that allows us to be able to get better bandwidth. Better bandwidth. It always strikes me as crazy that my parents watched the moon landing live on TV, but I am restricted to a few kilobytes in 2018 from a sea turtle or a shark or a whale. It's kind of crazy, and I know I am blissfully naive to the technology of the satellite side of things, and that's why I work with smart guys like Andreas. But it just seems to me that we can do better, and that's sort of why this challenge is out there. We want to know how we can do better. So, Andreas, those are the few slides that I had to share. I'd like to give him an opportunity to talk, or should I hand it over to you?
Yeah. That'll be fine. So yeah, so just a couple of things. So this next generation of animal telemetry vision that we're putting together, we are pursuing multiple areas. One is the infrastructure, another one is also the data. So how do we properly manage the data and make the data available to those of you that need it, while being proper stewards of the data, right? And today there are 6 big satellites with a payload with the Argos receiver that are tuned to a specific frequency. We don't want to be limited to just one frequency. We want to be able to take advantage of the latest technologies. We also, in this infrastructure, we're also defining all layers, right? So to be able to track on water, not underwater, but on the surface of the water, on land, also on the stratosphere, and finally in space. So we want to be able to define those different layers of our infrastructure, new infrastructure architecture. So while doing everything in an open source fashion, properly documented and available to everyone.
Fantastic. Thank you, Andreas and Jake. That's a really phenomenal introduction to the Q&A discussion we're about to start. I'm going to share my screen and really quickly just show everyone where everything's going to happen on this challenge, where kind of the hub of the activity will be. I know some people may have not signed up for the challenge yet, so this will just be a really quick overview. And I'm just going to take a minute or two to do this. So this is the challenge page. This is where all the information that you need lives. You can go ahead and accept the challenge if you haven't already. That'll sign you up for it. Make sure you receive all of our updates. And then there's some really great content on here that you should take a look at. The one being the guidelines. This essentially tells you what success looks like. You heard a little bit from Andreas and Jake about that, but this really gets into the detail. It also covers things like the timeline and what your submission needs to look like. Once you click this accept challenge button, you'll see a new one that says begin entry. And that's where you'll see all the fields that you require on your submission form. The one other item I want to show you here before we jump into the Q&A session is the forum. So if you have any questions following this webinar, feel free to put them in here. I don't know if Hugo's on the call, but Hugo, we've got your question queued up to answer it on this webinar, and then we'll also post the response on the forum here. So feel free to reach out there as well. Okay, awesome. So once again, just a reminder, there's a Q&A box at the bottom. Please do put your questions in there as they come to you, and we'll try and address as many as we can. These guys are brilliant. They may not have all the answers right now. So if not, then we'll make sure we follow up with any questions that we can't answer after the call. And same thing if we run out of time. So I'm going to start off with this question. Sorry, one moment. So the question is, why can't we just use tags with GPS capabilities? And what do we currently use instead of GPS tags, and how does that work?
Okay, you want to start that one off, Jake?
Yeah, so GPS, GPS is a great tool for animals that are on the surface and have a clear view of the sky. But the problem is that, even the fastest GPS chipsets still need to power up and receive multiple signals from satellites to get to know where they are on Earth. The problem is, by the time even the fastest GPS chips power up and are at the surface, the animal will have dove down again. So time is a big problem. GPS also, when you have a GPS antenna on a tag, I think from what I understand, and I'm not an engineer, I think those are really power hungry. So part of the problem there is, how do you have something on an animal that can last the time and function in just a brief, second or two at the surface? These are animals that are not coming up for a huge amount of time, and we can't transmit through the water for this kind of technology. So that's really the basic reason why GPS. Andreas, is there anything else you wanted to add?
Yeah, so, and we do, some tags do have GPS.
Yep.
And so we don't discount GPS completely, but as Jake was suggesting, you know, some of these animals surface only for a few seconds sometimes, and being able to lock in with the GPS, you know, that would require a little bit more time. But we do use GPS for some of the tags. What do we currently use instead of GPS? So some tags, all they have is a transmitter that is tuned to the current Argos radios, right, at 401 megahertz, and it transmits the signal. And as the Argos satellite is passing by overhead, it picks up that signal, and it continues to pick up the signal until it disappears from the horizon. And as we collect this data, we use the Doppler shift effect concept. Once we have all this data, that'll tell us quite a bit of information, and that's how we can deduce the actual location and other details. We can refine that, you know, to a little higher accuracy using different filters like Kalman and other methods. But currently, the tags are transmitting. The receiver on the Argos payload picks up that signal, and we're able to use Doppler to make sense of that information.
Great, thanks, Andreas. Okay, my next question. Must it be a CubeSat? We're considering some other satellite buses and form factors that are still smaller than or equal to CubeSat volume. Is that okay?
Andreas, that's probably one for you.
Yeah, I was going to say, can you repeat the question, kind of?
Yeah, let me summarize it. Do we need to include CubeSats in our solution?
Yes, so I think as everyone, or most everyone knows, CubeSats are very prolific right now. It is a disruptive technology. It is an industry that has grown significantly. There is pretty much everything you need off the shelf now available to you to build a CubeSat. And this is one of the reasons why we thought this could be, you know, part of the solution, a significant and critical part of the solution. But it does not necessarily discount other form factor type of small satellites. It also, as we mentioned, you know, we're looking at the entire infrastructure architecture, and space is just one of the layers in that architecture.
Great,
yeah, I would agree with that.
Okay.
Okay, awesome. Lynn, this is a question for you. Can you talk a little bit about intellectual property for this challenge?
Sure, as soon as I figure out how to unmute. Yeah, so folks know we actually do these challenges as a government procurement in a way. And for these, we always ask for what we call a government purpose license. The IP still stays very much with whoever the winning solution we choose. The IP stays with them. The government just requests a license to be able to use, in this case, it will be, you know, the idea. And there's no interest on the part of the government. We're not a for-profit entity to try and turn this into something that the government is going to sell. And as has been made very clear, as part of this challenge particularly, the goal is to go toward an open source solution. So for almost all of these competitions, we just ask for a government purpose license, but the IP ownership stays with the winner.
Great, thanks, Lynn. Okay, so my next question here, let me see which one is good to go to next. So Argos uses the Doppler effect. Andreas, you talked about that a little bit earlier for location. Is this due to the small number of satellites and not allowing triangulation, or is there another advantage to using the Doppler effect? You're on mute.
Yeah, I just noticed that. So Doppler effect is actually, one of the popular methods of processing the data collected from space and also from other layers, even from the ground. It is also used because of the current limitation. There's only 6 satellites. We really don't have the coverage, and so that at this point that is the most effective way of processing the data collected.
Great. And what kind of encoding do our Argos satellites use? Do you know the bit per second rate offhand?
I do not. Bit per second rate. And that's one of the issues that there is very little documentation available to the public.
I see Todd is Todd Lindstrom, who used to work with satellite tags, from what I understand, just answer that question in the chat. At 31 bytes maximum per uplink, if that's useful.
Todd, we're going to have to promote you up here to a panelist so you can answer some of these too. That's awesome.
Thanks, Todd.
All right. Okay. So next question. Do you plan to implement a new generation of tags themselves? Can you talk a little bit about the focus of this challenge? There's a lot of development going on in the tag world. We're looking at satellites here. How do they tie together?
Andreas, you want me to take that first?
Please.
Okay. So I guess in a perfect world, if I could just dream for a minute and what was my perfect world like, we'd be able to use existing tags. There are already existing manufacturers out there who are making some great tags. What we'd like to see is, can the infrastructure around that allow those tags to actually realize their potential? Whereas now it's sort of limited by the infrastructure able to receive information from the tag. Sorry, I'm reading the chat questions at the same time, which just totally distracted me. So I don't think there would be a need for new tags. People are innovating tag types. People are always working on improving the software and improving the sensors on tags. I was picturing that this would be focused on the infrastructure to receive signals from telemetry. Andreas, does that jive with you?
Yes, absolutely. So there is quite a bit of research and development well underway right now on the tag side of the overall solution, including here at NASA Ames Research Center. NASA Ames Research Center is collaborating with USGS on a new tag technology, and yes, so they're focusing on making use of the latest technologies and for all different form factors. We want to be able to be compliant with all the tag technology that exists today, but also the tag technology that's in development. We want to take advantage of everything that's coming, and this is one of the reasons why this effort will take advantage of that, and we will also make sure that we document very well everything we're doing and open source it and make it available to everybody so that we can continue to making this the most effective way of tracking these animals and gathering as much data as possible in making it available to the science community.
Thanks, Andreas. Okay, so here's another question. When looking at a competitor or someone who works in the space of an aerial platform, so the infrastructure, can they participate in this challenge? We've been talking a lot about hardware and not so much on infrastructure. Can you speak a little bit to whether or not there's a fit there? And it may be the case that we can follow up with this person separately and see where the discrepancy is.
I was also looking at the question, sorry. Can you repeat the question again, sorry?
No problem. So how can an aerial platform, so infrastructure, participate or contribute to this challenge? We've talked a lot about hardware and not so much on infrastructure.
Yes. So we conducted a high altitude balloon flight a couple of weeks ago. Because as mentioned, we're looking at the all different layers within the infrastructure, the new architecture of this infrastructure. And it includes land, and it also includes air and the stratosphere. So I think Jake mentioned it just a few minutes ago. We're not discounting the possibility of using UAVs, drones, or someone has suggested at the CubeSat Developers Workshop at Cal Poly early in the year to also include a receiver on the airlines, right? These planes are flying everywhere. And so why not also look at the potential feasibility of having the airlines have a receiver that can assist us with this. Another possibility is companies like Planet. They're launching small satellites in dozens, in hundreds. They also have a receiver that they have open source, and that may also be a possibility. Why not also include a receiver that is tuned to be listening to our tags? So yes, we're looking at all the different layers of our environment.
Great, thanks, Andreas. Okay, there's been a couple of questions about what exactly is due on November 8th. What does the submission look like? What does it need to include? I'm going to start off addressing this one, and then anyone else from the panel is welcome to jump in and add to it. So what I'm sharing here is what the submission form looks like on HeroX. And this should guide you through everything that you need to include in your entry. So there's lots of different questions. We've tried to make it really straightforward for you to be able to communicate what's most important in your submission. So I would recommend opening this up early so that you can take a look at it. You can save it as a draft and come back and edit it at any time. So get it started on the platform. Even if you submit it and send it off to us, you're able to edit it up until the submission deadline. And just a reminder, how you find that is with this begin entry button that you'll only see after you've registered. So that's the kind of overall part of the submission form. There was also a question about documentation that we wanted to see. This is specific to, do you want to see structural analysis in the documentation, thermal, vibrations, anything like that?
I think that it would be kind of early on for looking at structural, thermal, vibration, shock and vibe. At this point, I think just looking at the functionality that the system being proposed by those participating would be of higher interest to us.
Awesome. Okay. So here's another one. What limitations exist for existing Globalstar or Iridium satellite systems and the animal trackers that use them?
So I can speak to that really quick, and maybe Andreas can chime in. But so Iridium and Globalstar are great services and allow you to be able to move a lot of data, and it's useful for land animals. Mainly because for the reason that they require a handshake. It requires confirmation of the tag speaking to the satellite, and that takes time. And when you're talking about a marine animal that's going to dive down, that doesn't work. There's time involved in communicating. It's also expensive. Argos data fees are something, but not as much as a per minute fee of Iridium, or Globalstar. So those things become sort of cost prohibitive. Andreas, did you have anything you wanted to add about that?
No, I think you captured that pretty well.
Okay, so we've had a couple questions about what kinds of infrastructure and hardware can you incorporate into your submission? This one's asking specifically if you can use windmills on the sea for extended signal range, but maybe you can just talk in general, like what is the scope or the world of infrastructure that people can look at here?
So, you know, I want to say I always have a hard time because I think about this question a lot, and there's a balance that I think that the perfect sort of competitor would strike here between feasible and reality and imaginative cool stuff, but stuff that doesn't really have that isn't likely to happen in the next, you know, in the future. So there's no reason why the future of animal telemetry couldn't have a common receiver that could be onboarded on things like wind turbines or large ships or aircraft, or, you know, like there's nothing, I think, limiting that, well, except for the, you know, logistics of doing so. But, you know, I think entrance like that, as far as improving upon infrastructure, I think that would be good. Andreas, I don't mean to keep deferring to you, but.
No, yeah, I think we had mentioned that already, that, you know, to really take advantage of current infrastructure that exists today, but at the same point, making it also realistic, right? I mean, we don't want to see proposed solutions that right off the bat, we know that are gonna take years or decades to implement for different reasons, not just technology not being ready, but, you know, there's also laws and other more bureaucratic things that may prevent us from implementing something. But we're really looking for, we know that the small sats, the CubeSat form factor have really come a long way. We know that, you know, there are many or several companies that are now launching dozens of these. We know that there's a huge effort right now to develop the next generation of tags that will be transmitting in different frequencies. We know that there's a lot of effort, and we want to take advantage of all that. I mentioned that we did a high altitude balloon test just a couple of weeks ago. We are looking at how do we also make use of the stratosphere. What can we use in the stratosphere to assist us with getting a wider coverage on land, you know, near the coast. There's also ground stations that may be part of the solution. Yes, this windmill in the ocean could be another option, another part of the solution. So yes, that's what we're looking at, but we want your ideas to also come with a well-defined means of implementing what you propose.
Thanks, Andreas. I think what these guys really just touched on is that, you know, this is phase one, right? This is the concept phase, the ideation phase. We're looking for what are those brilliant ideas that we haven't thought about yet to bring this all together. Now, there needs to be some scale of feasibility involved so that we can move forward with them. But really, we're looking for your kind of ideas coming from a different background, maybe a little bit outside of the space, maybe inside the space. What do you think is possible? Okay, so my next question now is, the guidelines mention that monitoring service providers for Argos use proprietary systems. Documentation on their telemetry is not available and do not have to comply with an open standard for transmitting and receiving data. This is something we want to change in our new system. We've talked about that a little bit today. Can you explain what you mean by telemetry in that and the proprietary nature of the Argos system?
Yes, so telemetry is that information that you gather, that you collect remotely, right? And it can be, in the case of the animals, it is the information that is inside the tag, which may be identifying the animal, which may be providing location, which may be providing vital signs of the animal, which may be providing vital signs of the environment surrounding of the surroundings. You know, it may be a number of things depending on the capability of the tag, depending on the needs that were defined for a particular type of tag. Telemetry is that data that we're collecting remotely, okay? And so one of the things that we quickly realized is that we were not able to find a heck of a lot of documentation related to how Argos defines its data packet and how it organizes the data to transmit it. How is it expecting the data to be formatted so that when it receives it, it properly processes the data, stores it in its memory on board its satellite, and then prepares it for download at the next pass over the ground stations. We did not find a lot of documentation there, and so that's one of the things that we want to make sure that we do well, that we document everything so that everyone benefits from that. That's what we mean by open sourcing it. Everything the entire design, everything we implement for this new infrastructure architecture, for this new document management architecture, all of that we want to properly document and of course also define proper stewardship of all this information, but we want to make all this available to those that need it.
Great, thanks, Andreas. While you're talking about open source, I think this is a good time to clarify one other question that came in. And I think in some respects you may have already addressed it, but just to make sure we tick all the boxes here. So is it a full open source stack, right? Are you looking for open source hardware for tags, open source protocol, open source buoys and floats, those items too? Or are we more so focusing on the receiving end right now that you're looking to be open source?
So when we define the infrastructure, that's going to be the receiving end, okay? And yes, and in defining this infrastructure, we will in essence be defining or work on a communications standard, and that we want to document properly. And yes, we also want to make that available in an open source fashion. Now, the details, the implementation details, we can document, but I think that that's also going to be in a case by case. It depends on because our vision is that there will be small sats in space that are going to be assisting us to collect this data that don't necessarily that are not necessarily owned by the government, that are not necessarily owned by us. We want to invite the community to assist us with collecting this data, and this additional nodes in this infrastructure will have a standard to comply with, that it's well documented, that they can use to implement their own systems.
Great. Thank you so much, Andreas. So we're just a few minutes over our 45-minute mark. So I'd like to start wrapping it up, but I love all the questions that came in. There's a couple that we didn't get to, so those ones we'll make sure we follow up. We're going to be posting this recording as an update on the challenge page. So again, if you haven't followed the challenge yet, go ahead and do so, and then you'll get it in your inbox when we share that. And we'll post the answers to these questions we didn't address as well. If anything else comes up, please comment in the forum. We're watching for them there. We'll make sure we get the answers to you so that you can move forward. If there's anything that's maybe specific to what you're doing or you don't want to share on the forum, feel free to reach out. But for the most place, the forum is the best spot to go for your questions. So with that, I'll pass it over to Andreas and Jake, if you want to say a few words before we wrap it up, and then we'll close for the day.
I don't think I have anything too profound to say, except I'm really excited to see what everyone submits, and I thank you all for your interest, and I'm really excited to hopefully change the world when it comes to tracking animals. So thank you.
Yeah, thanks to everyone for participating. I really encourage you to continue and submit your designs. We want to make sure that we leverage this incredible knowledge that exists throughout our beautiful planet. So please take on this opportunity to make a change for the better and to help us take care of our planet.
Awesome. And with that, thank you so much, everyone. Have a wonderful rest of your day.
Thank you.